Okay, so Oasis just gave me the code. His department was trying to make the messages into code. So now our department's job is to make these codes into a real message. Okay, so we see here the 1x3 matrices, which is the code, and we're gonna try to break it down. So, and then this is the main matrix, in which it's a 3x3. Okay, so now let me get a piece of paper. Solve this. Okay, so first of all, we need this matrix in order to solve this, to break this down into the real message that I'm trying to point out. Okay, so this matrix is only known by our company. So now, if someone tries to hack it, it's really hard to get. Okay, so to solve this, you can use a calculator or just do it manually. But manually, what I mean is getting this 1x3 and multiplying it each one. So it's a long process. So it's kind of bad. Okay, so now we're gonna get a calculator. Put it already set. Put our matrix here. It's -4, -2, 0, 2, 6, 8, -8, -2, 4. Okay, so now they just put the code right here. -14, -44, -116, -90, -14, -52, -80, -40, and 0. Okay, so these are going to be our 3x3 matrix, and the calculator I'm going to display as matrix A, and these are going to be our 1x3s, and they're going to be displayed as matrix B. And when you multiply this, the answer is going to be 1x3 matrix. So I like to put it right here. So it's going to be our answer. Okay, so here's the main matrix, and when you're trying to encode something, you're going to have to use the matrix, of course, the main one, but just inverse it. So you multiply your B and A, but your A matrix, you're going to inverse it. So when I'm encoding this various messages, I like to put my -1 here, so I remember I have to inverse it. Okay, so now it's time to use a calculator. Like I said before, you can do this manually, but it will take a lot of time. Okay, so now we turn it on. We're gonna go to second matrix, and you see a list right here. Long. You can put so many matrices, but we're gonna use two today: the main one and the 1x3s. Okay, so we're gonna go to edit to put in our numbers, which is my bad, the matrix A. Like I said before, I'm gonna use the main one. Okay, so it's gonna -4. Oh, my bad. So it's I forgot. So this part, you're telling the calculator the dimensions of the matrix. So as we can see here, the matrix is measured by columns and rows. So right here we can see 3 columns and 3 rows. So that's why it's a 3x3. Okay, and then right here is the 1 row with 3 columns. That's why it's a 1x3. Okay, so right here you're gonna put 3, enter, 3, enter. You put enter so the number stays in there. Okay, so now it's -4, -2, 0, 2, 6, 8, -8, -2, and 4. Okay, so now we get our main one down in matrix A. Now we're gonna go to edit again, but now go to matrix B right here. So enter. Now we're gonna put a dimension, which is a 1 by 3, my bad. And then this is gonna be our first thing, our first matrix. Okay, so it's the negative 26. And 120. Okay. So now you go second quit to exit the window, second matrix to exit the window again. Now I'm gonna highlight my B, 1 by 3. Again, do second matrix. Select your A, inverse it so you can get the encode it, and then you're gonna get whole numbers, and they're real. If you get negative, decimal, or square root, that's wrong. You did something wrong. Maybe you plugged numbers, you misplaced a number. It can be various things. So always double check and watch out. Okay. So now we're gonna go second matrix and go edit. Since we don't need to change the main matrix now, so we only have to change these ones. Okay, so let's get this. We're gonna change it, still the same dimension, so we're gonna keep it the same. So it's gonna be negative 214, negative 44, 116. Okay, so it's there. Second quit, second matrix. Highlight that B, put A, inverse it, and you get your numbers. Put it here. Like I said before, here's where I like to put my answers, and as you can see, it's kind of organized. And this is like multiplication equals this thing. This 1 by 3 matrix. Okay, so again, just do the same process. The same dimension. So negative 90, negative 14, 52, second quit, second matrix, B, second matrix, A, inverse it, and boom, you get 19, 5, and 3. Okay, so now we're on the last one. So second matrix, but you edit, B, same dimension, negative 80, negative 40 equals 0. Okay, second quit, get matrix B, then get your matrix A, inverse it, and then you get 20, 0, 0. Okay, so we got the encoded part. So now these numbers you're gonna put them, you're gonna change them into letters. Okay, so every single number here, including 0, it has its letter, but 0 equals 0 right here, equals dash. And how do you know 14 equals a letter or something? So how this number scale goes is alphabetical. 0 equals dash, and then 1 equals A, 2 equals B, 3 equals C, and it goes on all the way up to Z as zebra. Okay, so we're gonna set our numbers. So 14, 15, 0, and now I'm gonna leave a decent gap right there, so because we need it's a space. 18, 5, 19, then another 19, 5, 3, and 20. Okay, I just got an emergency call from the office that this matrix right here, or this code, was incorrect. So now we know it's a negative 78, negative 8, and 52. So that would have affected the whole message. So that was a mistake by them. Okay. So we're gonna change that over here. Just cross that out. No need to do a big scratch line messy. Okay, so now just make a clean error over here. The code they gave us was negative 78, negative 8. Let me make that wrong. Negative 8 and 52. Okay, so now let's put in the calculator again. Same thing. Edit. Now let's put the same dimension. 3. Okay, so it's negative 78, negative 8, 52. Second quit, second matrix. B, A, inverse, and we get 16, 5, 3. Okay, so now, okay, these numbers were correct, so that's pretty good, but this one wasn't. So now we're just going to change it into 16. That's the correct number to use. Okay, so now we have our 14, 15, 0, 14, 15, 0. We have our 18, 5, 19, 18, 5, 19. Then we have 16, 16, 5, 3, 20, 0, 0. Okay, so that's correct. So now it's time to take these numbers and turn it into the real letters. So okay, so we know 14, it's N. 15, it's 0. 0, it's that. It's under dash, I guess, but this dash equals space. It's like a little space bar right here. Okay, so 18 equals R, 5 equals E, 19 equals S, 16 equals B, 5 again is E, good mistake there, 3 equals C, 20 equals T, and then zeros are just spaces. So the message of the office was no respect. So that concludes our project. The main focus was matrices, how to put them into code and then encode them. So those are our project, the Jabsters. Thank you very much. Hope you enjoyed this video. Thank you.